So before we get into JavaScript, all the basics plus some more, was there any like stuff from last week that y'all had like any questions about? I know that was kind of rushed last week. Okay, if you do, you can just drop them in the chat. I don't know if I'll see them, but hopefully someone else will. Second thing, I know like we say we're grading these, but it's more of like we want you to understand what we're going over. So like don't really stress how perfect it is, but make sure you understand the concepts. That's what this bootcamp's for. And then also, we had that Git presentation last Thursday. Hopefully you're using Git to make the pull requests for posting the projects, submitting your work. Just kind of think about like how you could be using Git more, I guess, because really the only way to learn it is practice a bunch. And finally, ask for help. Like this is probably all new stuff, and I'm more than happy to help you. So yeah, just DM me. Like I'm always on my computer, so I'll respond. Okay, so now on to actual JavaScript. Here's kind of the outline of what we're going to talk about. Like what is JavaScript, the fundamentals of the language, functions, and understanding what DOM is and how event handlers work. So what is JavaScript? HTML and CSS, they only take us so far. Y'all might have seen that last week. Like, okay, it's just a static site. Like, it's not moving. And a lot of the sites you probably use do move a bit. So it's like, something's missing here between what I have and what I want. So that's where JavaScript is going to come in. It fills in a bunch of those holes. And it doesn't just work on like websites, web apps, desktop apps, mobile apps, some operating systems, microcontrollers, and other programming languages also use JavaScript as like a base for them. So it is a super powerful language. For this bootcamp and Hack for Impact really, we're only focused on using it for web development. So that's what we're going to be focusing on. And lastly, JavaScript and Java. If you've used Java, you might be like, this is just Java part 2. No, they're not the same. They're not really related outside of both being programming languages, but that's pretty much as far as the relationship goes. Like little fun fact, I guess, JavaScript got its name just because the creators are like, Java's pretty popular, like let's just tag script on the end. Hopefully people will use it, and people do. So, that worked out pretty well. So JavaScript in the browser. Hopefully by the name, you can tell it's a scripting language. So we can do some programming things with it, like adding and removing new HTML elements to the page. So like that takes away all that cumbersome like typing tags out all the time, manually putting in more info. Like I find that really tedious. I want to not do that all the time. So this will help. We can respond to user inputs like mouse clicks, fetch data from APIs, and just a ton more. It's a full programming language, so it's really like up to how creative you can be, I guess. There are a lot of frameworks for it also to kind of make things easier development-wise, but we're just going to be focusing on vanilla JavaScript for now. That's just like no frameworks, purely what's in your browser. And I think, yeah, next bootcamp, we'll actually be figuring out how to talk to APIs. So it's like the World Wide Web will become connected now. Pretty neat. And there's also JavaScript on the back end, but that's going to be next week, I think. So getting into the fundamentals, I guess before we start these, if y'all have like any questions at all, feel free to just unmute and talk. I don't know how much you guys know, so yeah, feel free to just hop in whenever. So first off, we have variables. These are kind of like the building blocks of data. And we declare these with let or const. There's also var. If you go on Stack Overflow, you'll probably see that a good bit, but it's kind of weird in the way it's scoped within functions. So we try not to use that. There's a little example right there. Right here, like let age equal 20, const name is Ethan. So it's a constant, so if we try and change it, it's just not allowed. So let you could change, so age could equal 21, pretty exciting, but constant is a constant. And then also on variables, JavaScript is kind of loosely typed, meaning I don't have to say age is an integer. I just kind of say like age equals 20. And then JavaScript actually infers like, oh, okay, 20, that's a number. Ethan, that's a string. There's also Booleans, objects, functions. That's a whole type. And also undefined. But we'll get into more of how like functions and undefineds are types of variables in a bit. With objects, this is kind of, I guess, like a really powerful feature of JavaScript. We have these things called JSON objects, which stands for JavaScript Object Notation. And if you've used Python or Java, it'll be really similar to dictionaries and hash maps. So just like super quick lookup times. You can really store whatever you want in there. It's a key value pair kind of deal. So you can see here, like within the teacher object, you have my name, Ethan, age 20, likes coffee. Yes, I do. So that's like an example object. You're able to access elements of it or set elements or keys and values within an object using either a bracket or a dot notation. So these are both equivalent. The dot kind of is a little cleaner looking, so you'll probably use that, but the bracket allows you to put variables inside of there. So like if you're iterating through a loop and you want to change the key, you'd want to use brackets. And objects are also mutable. So going back to the previous slide with like let and const, you might think like a const object like teacher, you can't change. But an object's mutable, so you actually can kind of change it. That's, I guess, kind of like what these dots do. Immutable objects are more primitive types, like strings, numbers, and Booleans. Once those are set as constant, you just cannot change it. Hopefully that's good on objects. Please just jump in if any of this isn't clear. We also have arrays. These are pretty similar to objects, except they store more of a list of things, and this list can be really any length, and it preserves the order of how you add things. So objects, it looks like it might preserve that order, but I mean, it's a key value pair, so it could kind of shift around as you add more things. Arrays can be declared really any one of these ways. There's also like equals new array parentheses, but I mean, that's like way more characters than you need if you could just do these square brackets. So we kind of declare them this way, like, empty. CS and math could be in an array, and you can even mix the types of arrays. So that's where that loosely typed language kind of comes into play. Although like that's pretty messy. So try not to do that if you can. And arrays have some methods with them, or functions. You can add things to array with array.push. So that's kind of like subjects.push philosophy. Boom, you have philosophy now. And you can also remove elements from arrays with pop or shift. Pop would remove from end, and shift removes from front. And when it removes it, it also kind of returns it. So you could say like class equals subjects.shift, and all of a sudden you have CS in class. And similar to objects, arrays are also mutable. So you're able to kind of change it even though it says constant.
A quick question.
Yeah, for sure.
So do arrays in JavaScript support indexing? Like, can you like insert something into an index?
I'm pretty sure you can push things into it, but yeah, these are all, or push it into a certain index, but these are indexed. So yeah, order does kind of matter. You can iterate through it like you would an array in Python or Java.
Okay.
Okay, awesome. And then a little quick aside, kind of related to objects and arrays, we have a spread operator. So this lets us take everything in um, like an array or an object and spread it out to put in another array or object. It has this dot, 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 like ellipsis, like that's how you write a spread operator. And like, I think the best way to figure out how this one works is just see it. So we have teacher Ethan 20 again. And then in bio, we're saying spread out teacher. And then there's also this description little attribute. So now bio would actually have all of that in one object. And likewise for arrays, you can spread things out. So you have jazz, 60s, local music. You can spread it out into like a good music array, and then the good music array would look something like this. One thing to note is you can't spread objects into arrays or arrays into objects. They have to kind of stay within their groups. Okay, and then we also have undefined versus null. These are some keywords you'll probably encounter fairly often. Undefined for a variable, it means this variable hasn't been assigned before. So if I just say like let x, x is undefined, like there's nothing associated with it. And then undefined keys mean that key just doesn't exist within an object. And null is kind of similar, except it should be more programmatically assigned. So if I'm like, I'm done with this data, I'm going to assign null to it. So for variables, it's like this once had a value, now it's equal to null. And keys, same kind of deal. Like the key exists, but I don't want any data with it. Those are conventions. I could assign undefined to a variable, but then it just kind of gets messy with what's going on. We also have strings. These are like words. It's a primitive type, and that means it's immutable. So if you set a string, like a constant string, you can't change it. It's kind of set in memory. If you say let, you could reassign it. And on Stack Overflow, when you are Googling stuff, you'll see some people use single quotes and double quotes. These are functionally the same thing. Just kind of pick like whatever looks prettier to you. Single quotes are pretty nice looking. But you can't like mix double quotes and single quotes like on the same line. You have to stick with it. And if you do want to use quotes within a string, similar to other languages, you'd have to escape it with a backslash. You could kind of get around this if like you want to use a double quote in your string, you could use single quotes on the outside and vice versa, but that's just kind of like nitpicking, I guess. There's also the option to use backticks, which it's the key up by your one key on the top left of your keyboard. That lets you put variables within the string. So once again, Ethan, student, Ethan's the name, student's my job. I could build a string called description that uses the name and job variable. And so description would read, Ethan is an excellent student. Is that true? Probably not, but it's good enough for the example. And then kind of going on more with fundamentals, we have logging. So sometimes you'll want to see like what's going on with my variables, and you want to log them. This is kind of like printing, except JavaScript gives you a little more functionality, a little more power to see what's going on. So console.log is the most typical. It just kind of prints whatever you put in it. Console.table is a pretty special one. It lets you lay out arrays and objects pretty nicely, like it makes a table. And then you have warn and error, which lets certain messages stand out a bit. That's good for debugging. Like, hey, if I hit this error, like make it red. So we could actually see that in this console here. So if we say like let x equal 4, that's normal. And then we can log x. And if you want to just think in your head, like what's going to happen, we get 4. So that's like how you log a variable. To see the more fancy table, we are gonna set this massive array of objects as directors, and then we'll do console dot table directors, and this will make a super pretty like index, name, year, and position. So it helps you read through those arrays of objects a little quicker than if you had to read it like this. Like that's not even opened. So then you look like this, and then you'd have to go in each one. Like, no, that's not easy. Just use console table for stuff like that. And one more thing on fundamentals I didn't really make a slide for is when you're checking equality of two variables, because JavaScript's not a strongly typed language, you could get away with using an equality operator like equals equals. So like x equals 4. I could actually show that here. X equal 4, and we'll get true because I set it as true or as 4 earlier. We could also say x equal 4. That's also true. So it's like, what's the difference? We could get away with stuff like this, like x equal a string of 4. That's kind of weird. So we use the triple equal equality operator to kind of say like, hey, we care about the type too. Don't change a string into a number for us when you're comparing this. Hopefully that makes sense. Sorry, there's no slide for that, but that is something a little goofy about JavaScript.
What was that like website or IDE that you're using to write in?
Oh, okay. So I actually just opened a new tab, hit inspect element, and just went to console.
Oh, okay.
So
What do you
yeah.
normally use? Is that what you normally do? Or?
No, I mean I write everything in Vim, kind of like elite, but
also, this does also exist in Chrome. You can do the same thing and use Chrome DevTools to pull up the same kind of console.
All right, thank you.
Yeah, cool. So that kind of covers all the fundamentals. Hopefully that all made sense. I'm sure it did because y'all are super smart. If not, definitely just message me because I want you to understand this stuff. And now moving into functions. So kind of right off the bat, functions are treated as first-class objects. So this puts them on the same level as strings, numbers, booleans, and objects. So you could pass them around like you would a string, pass them around like a number. It's kind of weird, but it's just part of JavaScript. And that means you can also let them live within objects. So one of your attributes of an object could be a function. So it really lets you get messy with them. If you don't know what functions are, you could kind of think of them like a vending machine. So like if I punch in B4, I'll get M&Ms out every time. So it's kind of like logic like that. And then kind of more with the vending machine analogy, they're everywhere. You're gonna have functions all over your code. Vending machines are everywhere, kind of a rough comparison, but hopefully that makes sense. If you want it more technical of a definition, functions are reusable pieces of logic. So declaring functions in JavaScript, we have two ways of doing this. We could either say like function, name of function, parentheses, quote, brackets, and then the function, which is the function keyword, or use an arrow notation, which looks more modern. And it kind of highlights like this function is a first-class object. Both of these are functionally the same, like they'll work the same way. If I call hello world, it'll print out hello world. It doesn't matter which notation I use for this.
Do you specifically need that equal less than sign or equal greater than sign?
Yeah. So
okay,
that's a specific arrow notation. I couldn't do like a minus, like a minus sign instead of equals. It's just kind of how JavaScript wants you to make an arrow.
Okay.
So that's probably new if you haven't coded in JavaScript before, but it really does highlight like a function is a first-class object. Functions can also take parameters. So in that previous example, it would print out hello world every time. That's not too interesting. It's still super cool. Like you're making a computer talk. But with passing in parameters, now we can make it like actually converse with us kind of. So this would be an example of passing in a parameter using the function keyword. This looks like Java. And there's also the arrow notation. So kind of in here, you're saying like hello world equals the parameters arrow function and then the function. And if I called hello slow, it would print out hello slow. Yeah, so I'm a fan of arrow functions. I think they just look cooler, but saying function hello definitely also works. With functions, we can also return the values that they compute. Any type can be returned. So, I mean, hypothetically, like you could return another function from a function. I can't think of why you'd want to do that right now, but you can return objects, and this lets you kind of hold on to what it returned and use it later. Arrow notation also gives us the ability to do implicit returns, which means we don't have to say like return this. It'll just return it because it's an arrow function. So here'd be an example of this double function with an implicit return. We just say double equals num arrow num times 2. And you may say like, oh, where are the parentheses around num? But because it's one attribute or one parameter, JavaScript kind of knows like, hey, that's all we're taking. Just go on with the method or the function. You could also do multi-line implicit returns by putting little parentheses around whatever you're returning. So this getBio function, it takes in an artist and it would return the name, an object with a name and a genre. So this is kind of what it'd look like if I threw in Beach Boys. Pretty good surf rock band if you haven't heard them. So hopefully that all makes sense with returning values from functions. Pretty hot in my room. Sorry, I need to get some water. Okay, also on the line of functions, we have declarative functions. So declarative programming is kind of a different line of programming, a different paradigm. We're really used to imperative programming, which is kind of specifying like exactly what we want the computer to do. So in this example down here, it's like, okay, make an array called results, and then set a variable I equal to 1, and while I blah, blah, blah. Hopefully you can read that. If not, totally fine. I'm not trying to judge. But that's imperative. Like you're telling the computer exactly what to do. Declarative is more of expressing the logic of computation without describing its control flow, or just like letting the computer figure out how to do something. You just tell it what to do. For the most part, these are in the form of array helper functions. So like for each item in this array, map it to item times 2. So this whole line here is equivalent to all of this. It's just in a declarative fashion. And similarly, like it takes in an attribute. Like item would be each element as you're going through it. Hopefully that made sense. That's kind of like the index here. Some pros and cons of declarative programming. So you might have seen in that last example, like it's 1 line versus 8, I think. So it's cleaner code. It's easier to read. It's pretty explicit in what it returns. Like that map function, I know it's going to do this exact thing correct every time. I don't need to worry like, am I looping through that list properly? So it's easier to understand when you're just glancing at code and even finding bugs, because you know the problem wouldn't be in going through the array. It'd be in whatever that little function is. You're also able to chain operations. So with declarative functions, you could like take an array and filter out certain things, iterate over that result, and then map it to new values, all without ever having to assign any variables. So yeah, you could chain that all together in like one, it'd be pretty long of a line, but in one line you could do all that. And the biggest con is you're having to invoke callback functions, which is a function that runs on each iteration. And that does kind of hurt runtime, but I mean, you can kind of wait, like, do I want cleaner code or a little slower code? Like, that's kind of up to you. Some common declarative functions, hopefully their names kind of describe what they do, but there's like for each, map, filter, reduce, find, and includes. And there's more. You kind of just search for what you need in the moment and you pick them up as you go. The best way to understand these is to just practice using them. And there's a resource the great Ben Holmes has made. I'll post it in Slack or on the Notion or something, but it's basically like practicing declarative functions, trying to manipulate data a certain way. So that's all I have for functions. Hopefully all that made sense. Let me know if there are any questions. Okay, onwards. Understanding the DOM. So like, what is DOM? It stands for Document Object Model, and that's like a model of the objects in a document. In English, that's like how JavaScript sees the HTML on a page. And this is kind of like how we're connecting HTML, CSS, and JavaScript together. So we're finally able to like talk within the front end. If you're into math or nature, like a document object model kind of makes a tree. It's pretty cool. You can see it here. Like that's a tree if you didn't know. But here is an example of it in action. So this hopefully looks kind of familiar. This is HTML. And you can kind of see like, okay, there's a head. Within the head, there's a title element. Within the body, header, unordered list elements. And then this is how it would look in a model. So that's more of a conceptual model. We don't necessarily have to think about it unless we're traversing that tree. We may go into that a bit with React in a couple of weeks, but for now, you shouldn't really have to be like jumping up and down this tree. If you need to, let me know, because that might not be right. It's still fun to do though. So in order to select things from the DOM, or to manipulate things within the DOM, we have to select them. So this is kind of grabbing the right elements at the right time. Similar to how we talked about ID, class name, tags in CSS, that's how we kind of grab things using JavaScript. So here's some, like the actual ways you'd select an ID. You'd say document get element by ID, and then the ID name within those parentheses. And this will return just a single element. You should only have one of each ID on each page. That's just kind of how HTML should be presented. Then you have get elements by class name. Notice the S. So this is going to return an array of all the elements with a certain class name. Similar for tag, that'll return an array of all the elements with a certain tag. And there's also this weird one called query selector all. So if you've used some CSS, hopefully you have, you use query selector all in the same form as kind of making a specific CSS call. So like document.querySelector all p important class fancy ID would select this paragraph element. So it kind of lets you get pretty specific with what you're looking for. Once you have certain elements selected from the DOM, we're able to manipulate them as we please. This is where JavaScript gets pretty exciting for me. It lets us modify the content and style of those elements, as well as like add and remove child elements. So we're really in control of the page at this point. Here's a quick example. Like if I had a paragraph ID with alert, I could select that ID, set it to this important variable name, and then I could change the style by important.style.color red, and I could even add text to the end of it. So I'm like pretty much in control of the web page at this point. Really, really exciting stuff in my eyes, at least. So that's kind of a quick overview of the DOM. Any questions on that? Okay, awesome. So the last kind of thing we'll cover with JavaScript is event handlers. So an event handler handles an event when it happens. Again, that's not a great definition. So a little better one is it waits for a certain thing to happen and it deals with it when it does. And by dealing with it, I mean it runs a certain kind of code. So yeah, they can really like wait for like a click. They could wait for you to copy something, press a certain key, or select something on a page, and then actually run code to deal with it. And I'll show you like an example of why you'd want to have these, because that's a fairly abstract explanation, I guess, of event handlers. So one super cool example is handling button clicks. This is like the hello world of dealing with event handlers, or of actually using JavaScript. It's like you push a button and something happens. So conceptually, to do this, we would add an event listener of a certain type, which would be click, determine the target of the event, which we'll go into in a second, and then run a certain type of code. So we're actually going to walk through like handling a button click. Kind of scary. I hope I don't mess up. But here we go. So here we have some HTML. It's just super simple. A button here, a little count here, another button here. There's some CSS in here, just so it's not super plain. That's not too important. What we're interested in is making it where you click a button and the count actually changes. So this is possible with JavaScript. So let's see if we can do this. First off, we'll want to start by adding an event listener. And it'll be when a click happens. And using our arrow notation, we're going to tell it like do something when you click. So just to show that this event listener is live, we're going to just log hi when it happens. So let's clear that. So now when I click anywhere on this page, we get hi in our console. So it's like, okay, we're getting pretty close. When we click, something happens. But it's like, it doesn't really matter where I click, we'll always get hi. So we're going to want to use this parameter we're passing in to determine like, what am I actually clicking? And we do that by throwing some if statements in here. So if event target, which says like, what am I actually clicking on? If the ID of that target is equal to, we'll do the subtraction button first. Let's log, I don't know, minus. So let's make sure that's working. Boom, yeah, now you click the minus button, you get a minus. If I click the plus, nothing happens, which is exactly what we'd expect from this logic, because we're not clicking the button with subtraction as the ID, just the add one, so it won't do anything. So let's go ahead and add some logic for adding. And then we'll say plus here. And now if we click the plus, we get a plus, minus, minus. So it's like, okay, the buttons are actually doing something now. This is pretty exciting, but this number isn't changing. So to do this, we actually have to get into the DOM model that we talked about a second ago. So I want to grab this element right here. And luckily, this HTML was set up perfectly for this. I can just say const count equals document dot get element by ID, and that ID is count. So now count is actually this whole HTML element here. And we could console.log count. It'll give us something a little weird, like that doesn't seem too helpful. This is actually a full HTML object. This console isn't showing it. But if you go into your dev tools and try something similar, you'll get just a ton of attributes that don't really mean anything. But like basically now we have count and we can mess around with it. So to update count, because we're doing plus and minus, we'll want to set up a function to change the actual value of count. So let's say constant update count equals direction. So it's either going to go up or down. And then we're going to say count dot inner text, which is an attribute of the HTML element. So it'd be 0 in this case, equals count dot inner text plus direction. And then up here, we'll replace these with update count. And then for subtraction, we're going to go down. And then addition, we're going to go up 1. So pretty fun. You might think this works, but we'll actually get this like pretty weird behavior. It's just appending to the string because it's treating that 0 as a string, not a number. If you really want to get weird with JavaScript, if you turn that into a minus and then you flip these, it works for some reason. That's really funky. But like when you put the add in a string, you're going to append, subtract, it's going to assume it's a number. It gets really weird. So we're actually able to like cast this into a number instead of keeping it as a string. And we do that with this little notation here. So now, ooh, okay. I don't know if it's
left it as minus instead of plus in the update count.
Oh, thank you. Yeah, okay. So now we have our counter and it works going up and down. So that's just a super quick demo of like how you can make a button click work. And yeah, thank you, Finn, for catching that. That's might have taken me a minute. But yeah, super quick example of an event handler that works on certain button IDs and actually updates the DOM. So hopefully that gives you a pretty decent like understanding of how these all mesh together. Do we have any questions about that demo or anything from before that? Okay, awesome. So now it's your turn. We have another project task for you. Just a little foreshadowing. There's going to be 2 tasks this week. So I'd recommend like not waiting until Monday night. I know I would do it and I'd push off whoever said like start early, but you might want to this time. It shouldn't be too bad. I just don't want to be stressing y'all out. So between now and next Tuesday, you're actually going to be doing some event handling and DOM manipulation with JavaScript to modify the serving sizes of your recipes and update the ingredients accordingly. Like, it's kind of crazy how what I just talked about is a way you could accomplish this. And this video will be on the Notion. So if you're stuck, check the Notion out. This is what it kind of looks like. So we have salsa here, 8 servings, and these are the amount of ingredients you would need to make it. If I hit like, no, 8's not enough. I want 12. You see the ingredients updates with it. So that's what you're going to be doing. There's going to be more details on like specs, but that's just a high level overview of hopefully what you're going to be able to accomplish. And then looking ahead, so on Thursday, I mentioned we'll have 2 tasks. We're going to be dealing with APIs and how to talk to other computers using JavaScript on our browser. There'll be another task associated with that, or project task. So yeah, I don't think y'all want these doubling up. If it's too much, talk to me. I don't want to be stressing y'all out. And we'll also dig deeper into how JavaScript really works so we understand a bit more about what's going on under the hood. Yeah, and then, okay, that's kind of it. We're done with the bootcamp part 3, I think now. Finished, haha, it's Finn. Yeah, so I'll post all those project specs on Slack and the link to the Notion page. I'll actually send it in chat in case y'all don't have it. But make sure you join the CP Bootcamp help channel in Slack if you haven't already, because like, I don't know, I just want y'all asking for help. You can also DM me if that's uncomfortable. So thank y'all for listening to that. And last thing, there's the link to the Notion. I would recommend bookmarking that. It's super important. There's no ego attached to that at all. I would just bookmark it. Yeah, so that's all I have for Bootcamp. Thank you for listening. I have no idea how long that was, but we made it.
Awesome. Thank you, Ethan.